Let's have certain examples of the same reaction, that is the base assisted elimination reaction. Let's have some examples of that. Let's take an example of CH2 Cl CH3. We are going to use the same reagent, that is alcoholic potassium hydroxide, that is alcoholic KOH, and heat. Now, when we have the alcoholic KOH and heat, this reaction is also a 1,2 elimination or alpha beta elimination. In this case, this is the alpha carbon to which the halogen is attached, and this is the beta carbon attached to the alpha carbon. A beta hydrogen is eliminated out in this reaction. We have only one beta carbon, so there is only one possibility of the elimination of beta hydrogen, and we are going to get CH2 double bond CH2 along with HCl. Let's say we have a compound CH3, CH2, CH2, Cl. Again, we treat it with alcoholic QH. We get CH3, CH, double bond CH2 plus HCl. Here, this is the alpha carbon and this is the beta carbon. Let's say we have a compound CH3, CH, CH3, and Cl. And again, we treat it with alcoholic KOH. We find that this is the alpha carbon and we have two beta carbons. So the hydrogen can be eliminated from any of these two carbons. What we find is here, whichever side the hydrogen is eliminated from, we are going to get the same product. Let's have another compound, CH3, CH2, 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 Cl. And here we treat it with alcoholic KOH. Now, when we find the alcoholic QH, then in that case, we get it CH3. There's only one option because this is the beta carbon, this is the alpha carbon. There's only one option and there is only one product that is possible in this particular reaction. So this is the product that we end up with. Now, let us say we have CH3, CH2, CH, CH3, and here we have Cl. Now, this is a particular case in which there are two products which are possible. Now, one product is going to be CH3, CH, double bond CH, CH3, while the other product is going to be CH3, CH2, CH, double bond CH2. These are the two products which are possible in this particular reaction. Now, if we talk about these two alkenes, then what we find is that this particular alkene has this as the alpha carbon, this as the alpha carbon. Now, this is what we have as the functional group in this particular alkene. This is the functional group. What we find is that these alpha hydrogens have a capacity to hyperconjugate with the double bond. We find this is a more alkylated alkene. In this case, we have only two alpha carbon, two alpha hydrogen, and in this case, we have six alpha hydrogens. The first alkene is more hyperconjugated. The first alkene is more alkylated. While in the case second alkene, if we form the particular alkene here, what we can say is that here the alkene is formed by the elimination or removal of least sterically hindered hydrogen. Least sterically hindered hydrogen, or you may even say most easily approachable. Most approachable hydrogen. If in a reaction the major product is the alkene, if in an elimination reaction the major product is an alkene which has more alpha hydrogens, that is a more alkylated or more hyperconjugated alkene is the major product. It is termed as Zeitsev elimination. Now here, this is the actual spelling of it, but the way it is pronounced is Zeitsev. So there could be certain books which give this particular spelling of this particular mechanism. So what we have understood is if in an elimination reaction, the alkene obtained is the one with more number of alpha hydrogen, that is more hyperconjugated or more stable alkene is the major product. It is termed as Zeitsev elimination. And a reaction in which the alkene is formed by the elimination of least sterically hindered or the most easily approachable hydrogen, then it is termed as the Hofmann elimination. It's not that each of the reactions is going to be done in the same manner. In this particular thing, we can have the Hofmann product as a major product as well as the Zeitzev product as a major product. In this particular reaction, if we have small, strong bases, then Hofmann elimination is less and Zeitzev elimination is more. So in this particular case, if we use alcoholic KOH as the reagent, or maybe NaOC2H5 as a reagent, the major product is going to be the Zeitzev product. While in this case, if we are going to use CH3, CCH3, CH3, OK, potassium tertiary butoxide, we have tertiary butoxide, then we end up with the Hofmann product. We need to understand there should be two possibilities for this reaction to be taking place. So here we can have the Hofmann product as a major product, or we can have the Zeitzev product as a major product, depending on the conditions. This is what we have as E2 mechanism.